This video will give an introduction to the imaging features of imaging total stations and multi-stations. The video focuses on Viva and Nova total stations and multi-stations that are powered by Leica Captivate. Imaging means through the use of a built-in camera, the live view from the instrument can be displayed onto either the screen of the instrument itself or transmitted to another device such as a controller. Using image-assisted surveying, the user is able to steer and aim the instrument without sighting through the telescope or even needing to be next to the instrument. All measured and designed data is overlaid on the live view as augmented reality, and the data is fully interactive. Using the Image Notes feature, an image can be captured at any moment, and then sketched on and linked to a point. Multiple images can be captured and stitched together to form a panoramic image. We will look at each of these topics in more detail later in the video. Using imaging has many benefits. Because the instruments can be aimed without looking through the telescope, there is increased aiming ability and speed in situations such as when sighting steep angles or when the setup is awkward. Eye fatigue is reduced when repeatedly sighting the target, and safety is increased by preventing unwanted exposure to the eye through the telescope. The aiming of the instruments can be done remotely, meaning it can be fully operated from a distance, such as when using the instrument in one-person mode, or when access to the instrument is difficult or dangerous, enabling otherwise impossible tasks to be completed easily. By seeing all data overlaid on the live view, it is easy to perform a real-time quality check of the data, meaning you can leave site knowing the data is correct. By documenting measurements with photos, points can be easily identified back in the office and checked against errors. By taking images of the site from different station setups, detail or missed measurements can be created when back in the office using Leica Infinity, meaning costly site returns can be avoided. Before looking at each feature in detail, let's see how imaging is made possible. All imaging total stations have an overview camera built into the telescope housing. This is perfect for seeing an overview of the instrument's current orientation, and is also useful helping to aim to targets. As this camera is offset from the telescope optics, the parallax must be corrected for, which is done by taking a distance to the object. With the parallax corrected, the precise crosshair is displayed, meaning the target is being aimed at correctly. If the instrument is turned more than about 3 degrees or 3 gons, the crosshairs will revert to the uncorrected state. The TS116 total station and MS60 multi-station have, in addition, an integrated telescope camera. This camera is coaxial, meaning it is built in line with the optics. Therefore, it has no parallax and also uses the same 30 times magnification as the telescope. This camera is more suitable for aiming at targets more precisely, especially over longer distances. Whichever camera is used, the live view is displayed onto the screen of the instrument or the controller with a video frame rate of up to 20 Hz, giving clear and smooth images to work with. The camera view is fully integrated in most apps where you can perform measurements, such as Measure, Scanning, Stake and Check apps. In the next chapter, we will look at how we can steer and aim the instrument using image-assisted surveying. Using an imaging total station, the user can tap on any part of the live video image which is displayed on the screen to get the instrument to point in that direction. This is known as tap and turn, and allows a very comfortable and quick way to point the instrument either roughly or very precisely to the object you wish to measure. There is no need to sight through the telescope and adjust the screws to aim at the target. Using the overview camera, the instrument can be roughly aimed at a target using the uncorrected crosshairs. By then measuring a distance to the object and correcting the parallax, a precise measurement can be made. The image can be digitally zoomed in up to 8 times using the zoom tools. The brightness of the image can also be adjusted manually, or set to automatic. By switching to the telescope camera, the instrument can be aimed very precisely to the target. Because the camera is integrated into the telescope, the image must be focused. This can be done manually using the focus wheel or automatically using the focus button. A single press performs a single autofocus. A double press performs a refocus, and pressing it for 2 seconds starts continuous autofocus. Focusing is also possible on the toolbar with single and continuous autofocus buttons. The zoom and brightness controls are the same on the telescope camera as on the overview camera. However, because of the telescope magnification and digital zoom, a very detailed view is possible, enabling very precise aiming. The tap and turn mode can be toggled to selection mode to allow interaction with the overlaid data, no matter whether it is attached CAD data, measured points and lines, or design information. The overlaid data is displayed exactly the same as in the 3D viewer, with many customizable object display options to allow you to view the data in the best way for the task. Capturing an image means a snapshot of the live video is stored. There are a few different ways to capture images, either automatically with each measurement, manually at any moment, or capturing many images together to form a panoramic image. To set up capturing an image automatically with every measurement, the camera settings must be accessed to configure the image content and capture page. Here we can set to capture the image for every measured point, for either the overview and/or the telescope camera if available. We can choose whether to automatically link the image to the measured point. We can also choose to capture with or without the crosshair imprinted onto the image, to check exactly where the telescope was pointing. Now with these settings, when a measurement is made in apps such as Measure or Stake, an image will be automatically captured and linked to the point just measured. To manually capture an image at any moment, there are 2 options. Either use the camera key on the instrument or controller, and the Capture Image tool will open, allowing a quick snapshot of the live video to be taken from any of the cameras available, which might include the CS camera, the TS overview camera, or telescope camera. The other option to manually capture an image is from the camera view of any app, to use the Capture button on the toolbar. The advantage here is that we can also capture the data that we see overlaid in the camera view and imprint this onto the captured image. This setting must have been set in the camera settings. Note that storing the overlay data will increase the time taken for the image to be stored. The time for capturing and storing an image can vary a lot depending on the settings and equipment used. When using a controller to remotely steer the TS, an image captured from the instrument must be transferred to the controller, and therefore will take longer than when capturing and storing images using the TS on its own. In the camera settings, for each camera there are settings for the resolution and quality. Changing these settings affects the image size, which has a big effect on the transfer time when working remotely. To reduce the image size, choose a lower resolution such as medium, and choose standard quality image rather than the highest. We will look at capturing panoramic images after the next chapter. Any image captured manually is first presented in the image viewer. Here you can simply preview the image before storing it, or use the sketching tools to annotate the image. The sketching tools enable you to make notes on the image by drawing or typing directly onto the image, allowing you to keep your field notes nicely organized and safe. Press Store to store the image to the job, and a message will appear asking whether you want to link the image to a point. Even with no link, the image is always timestamped and referenced to the TS setup station in Infinity. In the Images page of View and Edit Data, all stored images can be viewed, sketched on, and linked to a point. And if linked to a point, will also appear as a thumbnail in the Points page. Panoramic images are a series of images captured from the overview camera which are stitched together to cover a wider area. There are several ways in which a panoramic image can be captured. Using the Panoramic Image tool, after doing a setup, and during a scan. In this video we will look at the first two, as a separate video will cover scanning. Let's start with the Panoramic Image tool. This is accessed from a hotkey or the My TPS Favorites menu. Use one of the options to decide how you want to define the image area to be captured. In this case we will choose Single Row 360-degree Image. And next we just need to point the instrument to the vertical center of the single row and press OK. Now we choose how to control the brightness of all images. In this case we will let the first image set the brightness for all images, and we untick that we want to stitch the images on board. To use the panoramic image later in Infinity, it is not necessary to stitch it on board, as Infinity will do this to a higher quality, and it also saves time after the image capture. Now when we press Start, approximately 30 images will be captured automatically and will be stored linked to the current setup. The panoramic image capture is also available after doing a setup. Once the instrument setup is complete, a message will ask if you wish to capture a panoramic image. The process is then the same as we have just looked at. You could, for example, capture a single row 360-degree image centered at 5 degrees below the horizon from each of your station setups. It only takes 2 minutes on the TS and gives you a complete image overview from each setup. Once you have images that were captured from different setups, you can use Leica Infinity to import your data, and by identifying common features in the images, you can accurately create new points that were not measured in the field. This can eliminate the need to return to site to measure missed details, saving an enormous amount of time and money. Any image captured from the instrument can be used for this, whether it was captured automatically, manually, or as a panoramic image. A separate video will explain more about imaging within Infinity. This video gave an overview of the imaging features of imaging total stations and multi-stations. Other videos will look into other robotic total station features, so do watch those videos if you would like to learn even more. Thanks for watching.